This is the first video for section 7.4, and this is an important video because a good number of the problems or types of problems that we'll be looking at throughout the course involve working with reference angles. So whether they give you the angle measure in degrees or radians, I will show you an example of each one. You really need to be solid on knowing how to draw angles of any size. Okay, so we are given an angle measurement of 582s. Now clearly it goes past one revolution. Now remember, one revolution is automatically 360 degrees. So let's see how much more we need to add to this picture to get to 582. Well, 360 plus 180 gives us 540. So we're going to go half of a revolution. And so from 540 to 582, well, 582 minus 540 gives us another 42 degrees, which is about maybe here. Okay? So this angle is 42 degrees, which is our reference angle. So based on the definition that you can find in your ebook on page 547, it says that the reference angle is the acute angle that is made from the terminal side of the angle, in other words, where the angle ends or stops, and the x-axis. Okay? Now, the other thing that I want to bring to your attention, I've uploaded a handout that you may use called Reference Angles. And this is designed to help you calculate the measure of each one. But I think it would be helpful if you know how to graph it by hand and then determine how much more you need to get to the angle measure that they're asking for. So in this example, the reference angle measures 42 degrees. So now let's look at an example when they give you an angle in radians. Now remember, this is in radians because we have pi in here. So the angle measurement that's given is 13 pi over 3. If you look at the denominator, it tells you how we're going to split this up. So now remember, the solid horizontal line that I'm going over, well, let me do it in green. Pi is equivalent to 180 degrees, okay? Now, with the denominator being 3, this is pi over 3, which is equivalent to 60 degrees. This is 2 pi over 3, which is equivalent to 120 degrees. And this is 3 pi over 3. Well, we know that the 3's are going to cancel, which gives you pi, which is 180 degrees anyway, right? So if we keep going, this is going to be 4 pi over 3. Excuse me, 5 pi over 3. And then if we make a complete revolution, this is going to wind up being 6 pi over 3, which can be simplified to 2 pi, which equals 360 degrees. Okay? So I think it's helpful to draw a sketch like this so we can keep track of what it takes to get to 13 pi over 3. So let's do this. Now, each time we move, we're going to land on everything that you see in orange is going to represent a pi over 3 each time we turn, okay? So, and we're trying to get to 13 of them. So it's going to be 1, 2, 3, 4, 5, 6. Now remember, 6 pi over 3 is already 2 pi or 6 pi over 3, and we're trying to get to 13 pi over 3. So let's keep going. 7, 8, 9, 10, 11, 12, 13. So we land on 13 pi over 3. So we are in quadrant 1. And it just so happens that the angle that is formed between the x-axis and where this angle ends is pi over 3. So this is the answer choice that we select. Now, an alternative way of solving this, just in case you're not comfortable working with radians yet, you may want to review the video where you are having to convert an angle from radians to degrees. And just as a quick recap, the way to do that is you're going to take the given angle measure in radians and multiply that by 180 over pi. When you do that, that's equivalent to 780 degrees. Okay? So, let's practice drawing 780 degrees. Well, we know that 360 degrees is that full revolution. If we make another revolution, that will give us 720. So let's do another one. And we're trying to get to 780. So 780 minus 720 is 60 degrees. So that means we need to add another 60 degrees, and this is where the angle stops. So again, by definition, the reference angle is made with the terminal side and the x-axis. So they are asking for the measure of this right here. Now in degrees, it's 60, but since they clearly want our answer in terms of pi, we have to change it back to radians. So 60 times pi over 180 is technically 60 pi over 180, but because 60 can go into both the numerator and the denominator, we can simplify this back to pi over 3. So either way, this is how it's done.